We have been listening for aliens for 65 years. We have heard nothing, and there is a real possibility that the reason we have heard nothing has almost nothing to do with whether they are out there, and almost everything to do with the fact that we have been listening from the worst possible location in the inner solar system. That location is Earth. In April of 1960, a young astronomer named Frank Drake pointed a radio telescope at a nearby star and listened for a signal. He heard nothing. This was the first SETI search in history, and it established both a scientific field and a pattern. For 65 years, we have kept listening. The instruments have improved by many orders of magnitude. The result has not. No confirmed signal of extraterrestrial origin has ever been detected. There is a standard interpretation of this. The universe is either empty of other technological civilizations, or such civilizations are so rare and so distant that we have not been able to detect them. This is what people mean when they invoke the Fermi paradox or the Great Silence. There is another interpretation. It is that Frank Drake was, in retrospect, listening at a uniquely favorable moment, and everything that has happened since has made the search progressively harder. When Drake listened in 1960, the radio environment of Earth was cleaner than it had ever been, and cleaner than it would ever be again. There were no cell phones, no Wi-Fi, no GPS, no satellite megaconstellations. The radio spectrum was, by modern standards, almost empty. If a nearby civilization had been broadcasting a strong signal, he had a real chance of finding it. Everything since has been downhill. Every year, humanity has filled more of the spectrum with its own transmissions. Cell towers, satellites, radar, digital broadcasting. Most recently, megaconstellations like Starlink, thousands of satellites transmitting continuously across the very frequencies radio astronomers most want to observe. Portions of the spectrum that were usable a generation ago are now effectively lost. For SETI, this creates a very specific problem. The signals we are looking for, technological signals, are narrow band, concentrated in a small slice of frequencies, because that is efficient and easy to distinguish from natural sources. But narrow band signals are also exactly what our own technology produces. Every satellite link, every radar system, every communication network. So when SETI detects something interesting, the first question is not, is this alien? It is this us? And the answer is almost always yes. The famous WOW signal from 1977 is remembered because it resisted that explanation. It could not be conclusively traced to human interference. It also could not be confirmed. Nearly 50 years later, its origin is still unknown. That is what a good day looks like in terrestrial SETI. Not a detection, but an ambiguity we cannot close. This is where the situation changes in a more fundamental way. Early SETI, including Drake's, was looking for beacons, deliberate transmissions from civilizations that wanted to be found. Beacons are powerful. If they exist, they can be detected across large distances, even in a noisy environment. Modern SETI has increasingly moved away from that assumption. There is a growing recognition that beacons may be rare, and that most detectable signals would instead be leakage, the unintentional radio noise produced by ordinary technology like our own. Leakage signals are much weaker than beacons, and they look exactly like the signals we produce. At that point, the problem is no longer difficulty. It is location. If you are trying to detect faint, ambiguous signals that look exactly like your own emissions, doing so from inside a planet saturated with those emissions is close to the worst possible strategy. So we have a search that has been running for 65 years, from a location that has steadily degraded, looking for exactly the kind of signal that location is worst at detecting. The null result is not strong evidence that the galaxy is empty. It is much closer to no evidence at all. There is a way out of this. The moon. The moon is tidally locked with Earth. The same face always points toward us. The far side points permanently away. From any point on the lunar far side, Earth is always below the horizon, blocked by thousands of kilometers of rock. That rock blocks terrestrial radio emissions almost completely. The far side is not perfectly silent. Solar bursts, Jupiter, and edge diffraction still contribute. But in the direction of Earth, it is quieter than any environment accessible to us by many orders of magnitude. The true radio quiet region lies near the antipode, the point directly opposite Earth, where shielding is strongest. An Italian astronomer, Claudio Maccone, has spent decades arguing that this region should be protected. He calls it the protected antipode circle, a lunar radio quiet zone where interference-free astronomy could be conducted. For most of that time, he was ignored, a specialist making a specialist argument to an audience that was not ready to hear it. What has changed is that the hardware is finally catching up. China's Chang'e 4 mission in 2019 provided the first direct measurements of the far side's radio environment from the surface. NASA's Lucy Night mission, scheduled for the mid-2020s, will test whether low-frequency radio astronomy there is practical. Larger arrays, hundreds or thousands of antennas, are being proposed, though not yet funded. These are early steps. The next decade will likely bring experiments, not definitive instruments. But that is enough to change the situation fundamentally. In science, the value of a null result depends on the sensitivity of the search. A weak search that finds nothing tells you very little. A strong search that finds nothing tells you a lot. SETI so far has been, in a crucial sense, a weak search, not because of its instruments, but because of its environment. The lunar far side changes that. A sustained search from a truly radio-quiet location would finally allow us to test a specific hypothesis, that our own emissions have been masking the signals we are trying to detect. If we listen from the moon and still hear nothing, that silence will mean something it has never meant before. It will not prove we are alone, but it will rule out one of the most important reasons we might have failed to notice. And if we do detect something from a location where terrestrial interference can be excluded by geometry alone, the result will be more credible than any detection made from Earth. This is the deeper case for lunar SETI. Not that it guarantees success, but that it is the first place where success, or failure, can actually be trusted. There is, however, a narrow window in which this is possible, and it may already be closing. The radio-quiet nature of the lunar far side is fragile. Every planned mission, scientific, commercial, or military, introduces new radio emissions. Communication relays, navigation systems, surface operations, individually reasonable. Collectively, they risk recreating on the moon the same interference environment that has made Earth unsuitable. There is no robust legal framework to prevent this. The Outer Space Treaty prohibits ownership, but it does not regulate radio use in detail. There is no protected quiet zone, no enforceable standard. If protection is not established before activity scales up, the opportunity disappears. The moon will become noisy, and with it, the cleanest possible SETI experiment will be lost before it is ever properly attempted. There is something striking about the timing. Frank Drake began SETI in a radio environment that was, in retrospect, uniquely favorable. He died in 2022 at 92 without ever seeing a radio telescope operate on the lunar far side. His successors have watched that environment degrade decade by decade. The lunar far side offers briefly a return to something like the conditions in which the field began, a second chance to run the experiment properly. But only briefly, only if the effort is made in time. 65 years after Project Ozma, we are finally in a position to listen from a place that is not fundamentally compromised by our own technology. Whether we find anything is unknown. The universe may be empty. It may not be. But for the first time, we are close to being able to run the experiment in a way where the result, whatever it is, can actually be believed. For 65 years, we have been listening from the wrong place. We are about to start listening from the right one. And when we do, the silence, if it remains, will finally be a silence we can trust.